Thank you. Good morning, everyone. My name is Shreya Venugopal, and I am one of the authors of the work, A Comprehensive Study on Various Statistical Techniques for the Prediction of Movie Success. I am from PES University, Bangalore, India, and my co authors are Rishab Kashyap, Manav Agarwal, and Professor Bharathi. So, movies are a field which generate a lot of revenue if the movie is liked by its audiences. So, it's always good to know what kind of movies are likely to succeed. So, we have taken movie data from IMDb and analyzed this to see if we can predict the success of a given movie. So, a system is created where an input of various characteristics about a movie is given, and the output is whether the movie will be a success or not. And in this way, the movies that will be made in future, we hope, will be those that would generate a lot of revenue for those who are making the movies or being part of the movies, and will be liked by the audience. So, the aim of this experiment is to predict how successful a movie is by looking into various approaches for doing this. So, we have looked at multiple machine learning models and time series models and also looked into their validity. We also look at the kind of attributes or features that contribute to a successful movie. So, this is a comparative study of all these models based on various parameters, and we plan to find the model that would give the most accurate results. So, the comparison between models is based on its statistical significance and various performance metrics like its precision, accuracy, and so on. So, coming to our proposed methodology, it consists of three steps. The first being data preparation, which involves collecting data from either pre existing data sources or from uh, the official website of IMDb. And it also involves cleaning the data up such that it is in a form that could be put into a machine learning model. The second step involves identification of attributes and creation of statistical models. So, here at the first stage, there are several feature selection processes to determine what kind of attributes we want for a single model. Then that model is executed and then it is fine tuned to see if it can perform better. The third step involves comparison of models and a final prediction. So here the models are first checked if they are statistically significant or valid, and later they are also compared with each other to see how one model is better than the other, and also to look at what kind of features are used for each model. So, coming to the data processing method, first is the data collection. This can be looked into from two aspects. The first is using pre existing data sets. We have taken data from Kaggle, which gave us movie data from 1910 to 2019. For our analysis, we have taken movies from 1990 because we thought that for the present day movies that are available, movies that are there from 1990 would give better results because the kind of social environment that we have is similar. Also, the data for before these years were not as populated in terms of giving accurate dates published and ratings and so on. The other aspect to data collection is web scraping of data from IMDb. So here the contents and attributes are taken from the IMDb official website, and we have taken data only for the year 2020. This acts as our testing data set, which checks if a model was built with data up to 2019, would it be useful for the year 2020? And this would give an indication of whether it could be used for years to come. So here is the data cleaning process. The first step involved is uh, detecting null values, that is, either empty strings or the word null itself, or maybe even in some cases the value zero. So once these values are detected, either if there are a lot of null values for a given movie, that movie is removed, or for depending on the kind of attribute that has the null value, it could be replaced with either the mean or the median. So the third step here is data integration, which involves combining all the different data sets. So when we were given data, it was in terms of different kinds of tables where one looked into only movies, the other with people who were involved in the movies, then one just looking at the votes that were given by the users and audiences, then one only for the ratings. So all this is combined into a single data pool. The fourth step is data scaling, that is bringing all of the data onto a common ground. So here I take the example of the feature budget, which showed values in various currencies. So we had to bring it to a standard form, which involved some conversion of currencies. So another important feature of our pre-processing method is the multi-label binarizer. So this was used to convert the genre of every movie into a binary format. This was done because for one movie there were multiple genres, and to enable easy analysis of data and a simpler classification process, we made it such that if a movie belongs to a certain genre, the value for that genre column for the movie will be 1, otherwise it would be 0. So this gives a very discrete form to the genre attribute of the data. This is the correlation heat map, which has been used to look at the interdependencies between the numerical values in our data set. As is seen from the darker brown squares that are present, there are a lot of pairs of attributes that are highly dependent on each other. So this shows that there is a lot of multicollinearity and interdependencies in the data, and hence when creating a machine learning model, one should make sure that the independent variables involved are as unrelated to each other as possible. So another thing that can be noticed here is that attributes that have a similar semantic meaning, like the various attributes that involve votes or those that involve reviews, are very highly correlated with each other. So when constructing a machine learning model with such attributes, one must always take either one or two from each of these groups to make sure that the model works in a better manner. So the variance inflation factor is another indicator of multicollinearity. So this finds which combination of variables can together form a good model. So again, for the vote related variables, the VIF values are pretty high, so it wouldn't be advisable for having a model with only these variables. So now let me introduce you to our target variable, which is the Metascope. The Metascore is defined by IMDb as a value that ranges from 0 to 100, where 0 stands for a very unsuccessful movie and 1 for a very 100 for a very successful movie. So this has been grouped into three bins because what we're trying to find out is, given a movie, whether it would be successful or not. So the first is those that show a Metascore value of 33% or lower. The second is mediocre, which are movies that show a Metascore value between 33% to 66%. And the third is movies that show a Metascore value which is more than 66%. So here are the models that we have analyzed. We have looked into regression models, classification models, and time series. So in regression models, along with the standard use of simple linear regression and multiple linear regression, where once a prediction is obtained, those output values are binned into the respective metascore categories. We have also looked into regularization methods because all of our independent variables were highly dependent on each other. So this wouldn't, if we are using a regularization method, it wouldn't involve much of a feature selection process. Also, we have included logistic regression, which is usually used for binary classification here, even if we have three bins for the Metascore, because we found it important to analyze logistic regression and use that as a model for our data because it's one of the most important and standard classification models. So coming to the classification models that are not regressions, here we have looked into um, a good variety of models. In the case that k-means is an unsupervised technique where we want to see if movie success prediction can be done even without the use of the metascore dependent variable. So based on the data values, if they can be put into different clusters. Then a support machine has also been looked into because of support vector machine has also been looked into because it is one of the standard models when there are a large number of independent variables. Artificial neural networks are models that give very high accuracies because of its learning rates for most problems. So hence we thought that it would be important to analyze this also for the movie success prediction problem to see even for this problem if it could give a highly accurate prediction. So time series models have been made by looking at a step-by-step analysis on based on statistical tests at each stage, where depending on the output of the test, we decide on the kind of parameters that should go into the model. So now going deeply into the regression models, simple linear regression was done for each of the variables that were present in our data, and the top 1000 voters rating variable gave the best results. This attribute shows moderate correlation with Metascore, and it on comparing the VIF values, it proves to be an appropriate variable to perform regression. But as it is seen in this figure, although the values are linearly dependent, there is a lot of distance for a good number of points from the regression lines. So even if simple linear regression might be a good model, it doesn't seem like it is the best. So coming to the multiple linear regression, here the attributes were selected uh, from the VIF values, and the figure on the right shows a sample of two variables that were used to predict the movie success and how it gives a visualization with respect to the metascore. Here it is important to note that it is not only these two variables that are going into the model, and they have just been sampled for this visualization. Here is the same visualization from different angles. Coming to logistic regression, this is a nonlinear regression technique to find out if there is a relationship between a qualitative and a quantitative dependent variables when there are several independent variables that are involved. So for this problem, the logistic regression gives an AUC value of 0.85 out of 1, which is very good. That indicates that the classification through logistic regression works very well. Coming to our regularization techniques, ridge regression uses L2 regularization, and uh, again, it is very useful since we have a lot of independent variables and they are interrelated to each other. So this multicollinearity is reduced by solution, which uses a central tendency to penalize the multicollinearity. Here, the regularization parameter is set to 0.145. Although what one would expect would be different results from ridge and lasso regression, in this study it is seen that both the regressions perform in an almost similar manner. Coming to the classification models. K-means classifier is an unsupervised clustering technique. Here, the number of clusters was set to three based on the number of Metascope bins that were there. And as is seen from the figures, the clusters are formed in a well separated manner. The support vector machine used in this case has more than one hyperplane because there are three categories into which the data needs to be classified. Coming to the artificial neural network, the kind of artificial neural network that has been used is a multi-layer perceptron network. So this consists of one layer with many neurons, and similarly there are many such layers in a sequential manner. So an Adam optimizer is used along with a logistic activation function in order to have a very fast learning rate. Here, as is seen from the ROC curve value, the area under the curve is very high, indicating that the classification is good. Another indicator that shows that this model has performed very well is that the loss curve shows a gradual decrease in the number of wrong predictions. So this shows that there is a very good learning rate. In order to reduce overfitting, we have taken the following steps. The first being reducing the maximum number of iterations to 1,000 cycles, and we have also implemented early stopping. So looking at the time series model, here this performs forecasting with respect to the date of release, and it aims to spot whether with time there has been any gradual increase in metascore or gradual decrease. It also sees whether the success of the movie depends on which month it was released in terms of seasonality. So here we have considered both time series parameters along with exogenous variables. Hence, we have made use of a Sarimax model. This allows for seasonality, looking into trends by differencing, autoregression, moving average, and also the use of independent variables. So we have the residual plot and QQ plots here that indicate that the um, classification is very good. This is how the time series model looks. So the observed data is given in blue, whereas what we have predicted and forecasted is given in orange. As is seen, the orange and blue lines seem to have very similar values. So now I shall talk about the statistical tests that were performed to make sure that these models are valid. For the linear regressions, we have the Durbin-Watson statistic, which indicates that there was no autocorrelation. This means that um, one movie's data does not depend on the other movie's data. So we have this assumption for linear regression proving to be true. Multiple linear regression shows the highest R square value, but its F statistic is not all that great as compared to ridge and lasso regression, but it is lower than simple linear regression, which has an almost similar R square value, so we can hold it at some merit. So for in terms of another assumption for linear regressions, which is the normal distribution of errors, all regressions except for simple linear regression are statistically significant. Coming to logistic regression, we have the Waltz test, which shows that from the chi-square values that this regression model is also statistically significant. So a silhouette test was done for the classifiers, that is the k-means and the SVM models. Here it is seen that although the silhouette score of k-means is 0.7 on 1, which is much higher than that for SVM, this shows that the kind of clusters that were formed for k-means was better than SVM. But when we look at the accuracies, we see that SVM has performed much better. So this shows that although k-means was able to form very good clusters, it didn't solve the problem of movie success prediction very well. So it shows that this problem can be solved better by using supervised learning techniques. So, coming to the results of the artificial neural network, which is the best model in terms of accuracy, we see that even for the testing dataset of 2020, it gives a 93% accuracy. It doesn't show any overfitting because of the kind of tests that were performed in order to kind of steps that were taken in order to prevent it. So time series analysis was performed in a way that for each based on the result of each statistical test, the kind of model was determined. So from the autocorrelation and partial autocorrelation, it was evident that the autoregression and moving average values should be around 1. The augmented decay-Fuller test indicates that the data is stationary. So when we applied some seasonality to the model, there was a reduction in the AIC values. So we concluded that there is some sort of seasonality in the data. And on adding exogenous variables, the root mean square error was reduced. So hence we came up with a Sarimax model. So we also look into a comparison of models that had similar accuracy, which were multiple linear regression, logistic regression, and SVM. Here we see what kind of attributes were easily available in the year 2020 and whether these attributes are similar to those that were used in the model. And here, as a measure of similarity, we use the Jacquard index. And as is seen from the data here, the support vector machine does best in terms of attribute availability. So here are the results of our analysis. We have the artificial neural network performing best. This is followed by the support vector machine over the multiple linear regression and logistic regression because it has better attribute availability. Then we have the k-means, which showed very low accuracy. So this indicates that supervised learning works better for this problem. And models such as simple linear regression and regularizations were proved to be statistically insignificant. Then we have the Sarimax model that could forecast the metascore very well, and it is also seen that none of these models used all the genre types. So it can be said that there is an influence of some genres on the success of the movie. So it can be said that some genres predict better than others. So I'm ending my presentation here. Thank you.
Yeah, thank you very much for presenting MID 2021. Any questions?
Thank you. Thank you very much. The presentation is wonderful.
Thank you.
Yep. Is there any, if you don't mind, can you explain the experimental setups, please?
So what we did was we took the data set from Kaggle, then took values that had a lot of data that is which weren't sparse in nature, and from those we performed feature selection using the variance inflation factor and looking at the correlation maps, and then we tried it on various models, and then we performed a comparative analysis on those models.
Great, great. And I have one more question. From your study, can you tell me what are the attributes play a major role in the prediction of movie success? So it will
Okay.
be useful for a lot of movie makers, isn't it?
Yeah.
Yeah.
So I think that some genres of movies, like as is seen here, like we have action, crime, drama, fantasy, mystery, thriller. So these genres seem to have some kind of influence on the success of movie. Maybe I'm not exactly sure if it gives a good movie or a bad movie, but if you have a movie of this genre, it would have a dramatic effect. Also, the uh, first set of ratings that come from the voters, that is the top 1,000 voters ratings, those play a very large, big role, I think, on how people judge the kind of movie. So whoever rates it first and the kind of ratings that come at that time is what the others also follow. So that's another thing that is important.
Thank you. Thank you very much.
Are there any other questions?
I think are there any questions from forum? I think the session chair is not here. I'm the session chair for tomorrow.
It seems no questions there.
Thank you.
Okay. Thank you very much.